it off there.
Thanks everyone for joining, and thank you, Jake, for presenting for us today.
Alrighty, this is gonna be pretty, agenda loose. Let's see what I want to talk about here is what you pitched on the dev list recently.
Clickety clack.
Who's typing? Okay. So one of the problems that we have with Geode and is common in a lot of large software systems is that you end up with a lot of code added to a lot of code, added to a lot of code in a way that makes it one giant monolithic thing. And if we look at Geode's history, it became fairly monolithic. It's starting to split out into small little submodules, but we can do a better job. We can do a better job when we're doing an RFC to add new features to make sure that we focus on producing that new thing in a way that doesn't add to the existing core code base, but tries to tease out some extension points and create some modularity in what we are doing. The benefits to that are, one, you don't have giant monolithic, blocks of code, large functions. You don't have objects that do 100 different things. We know from OO design that's a bad thing. And it allows us to test things in isolation. It also allows distributions to be shipped with different features available or not available. So what this presentation is mostly going to focus on is how to go about doing that. It's going to look at the most recent RFC work that was done on the transaction grouping, not picked because of any other reason than it was the most recent thing that I saw, and it was a good candidate for doing some sort of modularization. Now, when I talk about modularization, I don't mean going the full kit and caboodle of having, SPIs that any customer can go and implement and plug in different modules into the product. If we try to do that, we're never going to hit the mark, right? Like, that's just a big task. What we're talking about here is doing very low-hanging changes to the core code to allow us to hang new things off of that core code in a way that doesn't necessarily affect the core code, or at least doesn't substantially affect the core code. So don't think about, big modular systems and big SPIs. Think small. What's the smallest change I can make in order to put this code somewhere else, right? So that's what this is going to look at. So I'm going to first start off by just kind of bouncing back and forth through some code. If you have questions, interrupt, ask them, and we'll try to answer them as we go. So I'm going to share my screen. Just 1 second. Move some windows around again. Okay, share screen. All right, can you all see my screen? So you see some source code. It's in presentation mode. This is as big as it's going to get for my eyes. So hopefully you can read it. I'm going to start off with a shameless plug here that I've plugged multiple times. Clean up your code before you start working in it, or clean up the code after you've worked in it. The gutter should not look like this. It shouldn't say there's 39 warnings over here when I go into a piece of code, especially something as simple as gateway sender attributes is basically just a giant property object. Like, there shouldn't be this many warnings. Clean it up. There are bugs hidden in here. You will find them along the way when you do that. So clean up your code, please. Shameless plug over. Okay, so I'm going to get the presentation mode here. I'm going to skip ahead to a different spot in the code after I've cleaned up this class. Okay. Come on. Some serious lag here. Okay. So if we want to start figuring out how to modularize this thing, we know that a new feature generally starts with something. I want to add some new functionality to something, right? In this case, we're trying to add new functionality to the gateway senders. And if we look at how it was done, this is going to be a weird conversation that we're starting with something that was already implemented and trying to extract it into a module. You'd almost work the opposite direction, starting with the module first, but you're looking at the place of code where you're going to make some new decision, right? And in this, how do we switch classes in here? I want gateway example. If we look at the create method in here, we see that we make a lot of decisions based on, that's the wrong create method. In the wrong class. Sorry, just a second. I don't like presentation mode because I can never navigate in it. That's the one I want. We make a lot of decisions based on things that come out of this gateway sender's attributes, right? Those are behavioral decisions that we're making. And if we see down here, we're making this decision, hey, if it's parallel, I'm going to create a parallel gateway sender. If it's serial, I'm going to create a serial gateway sender. Well, this would be the logical place where I probably put in, hey, I'm creating different types of senders, right? Maybe I'm going to put in my naive sender or my dropping sender, whatever thing I'm going to come up with, right? So to me, it makes sense to start with, looking at how we're going to plug something into this particular location, okay? Just a second. So if we're going to start here, we know that we're dealing with attributes. I want to be able to test these attributes. And if we notice one thing about these attributes, this thing is a concrete class. And I'm passing it around to things, and I'm going to pass it into something I'm going to modularize. So it makes sense to turn it into an interface at this point. And we know that once I'm passing into, as we look at the code, as I pass it into one of these things, it's largely immutable. So let's go and create an immutable interface for this and make it a little bit more friendly for testing. So we're going to extract out an interface for that. And when we do that, we end up with some interesting changes. We find that, in no places do we actually, outside of that create method, do we end up mutating it, other than in this, when we're doing validation. So if we go to this checkout of this, back to that create method. We find that, hey, when I'm doing some validation, I'm setting some values here. And then there was another thing. If certain properties are set, we reset them to specific values. So there's also a need for this, for some mutable versions of these attributes when passed in, or when doing validation. So one of the things that I found when teasing out an interface for creating a factory for creating these things. So again, we're talking about, we want to create these based on the attributes. I want a factory that does that for me. So I'm going to check out this revision. And we can see now that I've moved some things around. We now have our, where did that create method go? Our old create method is now turned into a series of smaller methods. So when we refactored some of the stuff out, there's a validate phase that happens now that's on all attributes. This applied to all of the different types of senders. So that was that large chunk of code we saw earlier that was, actually we go down here and look at this. Oh, that's probably too big to view. We had all this block of code here of, if DS system ID, blah, 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 blah. That all got moved out to some validation block, okay? Just to isolate it away. And then we create these factories, depending on, the settings in our attributes. And so in this case, that block of code that was just doing if parallel is now creating factories instead of actually creating the implementation. And then we go on and we validate the attributes against that factory. So if we looked at the original code, parallel had some extra rules and serial had some extra rules. And those are getting applied here in this validate phase. And then we actually end up creating the actual gateway sender. And there's this weird behavior of, it's like old holdover from cache XML, where there's actually this cache creation object. We're gonna just pretend that doesn't exist. So don't look at that, ignore that. But if we're creating a gateway sender for the actual cache, we just tell the factory to create it, passing in the stuff that we had passed in originally, but now it's going to a factory. So we've now isolated away both the validation and the construction of these two original, although they do have the transaction stuff in it, the original gateway sender types, okay? Any questions up to this point? Okay. Oh, somebody unmuted, I hear, clicking.
There are some questions in the chat. I don't know if you saw them.
I can't see the chat, so somebody want to...
They were mostly about your IntelliJ wizardry.
Okay.
Bill wondered what you did to see the warnings and typos, and Alberto wondered how he did to clean them up with a single click.
You can click on the checkbox, or basically this warning box up here. That should be on by default in your IDD, and it does bring up the problems box down here. You can see that it went from like 40-something warnings down to 4. The 4 warnings are that we're still using is manual start in multiple places in here while it's deprecated. There are ways to get rid of that warning too. First off, deleting the code that's been deprecated forever, but and it's internal code, so we should delete it anyway. And then what was the other question? Sorry. Oh, how to clean them up and with a click. There is a option to like clean up, apply code cleanup to the whole file in one shot. But I like to try to understand what's going on, so I actually just do it one at a time. And there's keystrokes that will take you to the next error or next warning, and then Option Enter gives you the fix for that. You can also just click on them down here, and it'll take you right to it. Option Enter brings up things like, okay, in this case, it doesn't know what to do about a deprecation, but you can tell it to suppress it if you wanted to. But if it was some other kind of change, it would give you options on how to change it, how to fix it. Okay, so that's great. We've modularized effectively the first 2 original or I guess encapsulated. I wouldn't say modularized yet. We've encapsulated the first 2 original gateway senders off into their own factories as kind of a starting point. And now we want to think about, okay, well, now there's this transaction code in there. I want to extract that out. And that's where it starts to get a little tricky, because we're now talking about extracting code that we already put in. But if we go and look at what makes a decision about doing transactionally grouping stuff, we'll find where to extract those. So first, we're going to start off by creating factories for those, right? Like I got to be able to construct them. So if I go check out this revision, go back to this thing, back to create, away, box. My layout got all messed up. Okay, so we want to get our factories now. Now we'll see that in this first step in trying to tease out this transaction grouping thing, we have attributes on our attribute object that tell us we're going to use this transaction grouping. And so that would be our decision point, right? I'm going to do parallel and it's doing transaction grouping, or I'm doing serial and transaction grouping. So now it can create one of 4 factories here. Okay, still rather hard coded, not super modularized it, but we're trying to do encapsulate some things. So if I say I'm creating this TX parallel grouping sender factory thing, this is simply right now an extension of the parallel gateway sender type factory. Cool. So it's effectively creating the same thing that it was creating before, but I've started that separation, right? There's a new factory, and we can see that this factory does some different stuff on validation. So one of the things that I did in this particular change was pull out gateway specific, or sorry, that's not right. Yeah, pulled out some, some parallel, or not parallel, some transactionally specific checks that were in the serial gateway sender have now been pulled out and put over in the new TX grouping serial gateway sender. Now has its own validate method. It calls some common TX transaction grouping validation, but also this particular one that was embedded in the serial sender. So since this is always transactional, we can get rid of that check for the attribute because we won't get here unless that attribute is true anyway. But if we have more dispatchers thread than one, we're going to throw this exception that it was throwing before, whatever that meant. So we've now taken and encapsulated really the construction and the validation of those attributes now in its own factory. Okay. But we can see that it's still creating the serial gateway sender impulse, the serial gateway sender creation object. Again, ignore that one. But we're still creating that serial gateway because all that transaction stuff is still embedded inside of that. So if we want to try to tease out, we need to look at, well, where are we making decisions about doing the transaction differences, right? Where are we doing transaction grouping stuff? And if we look at serial gateway sender impl, for example, if we go in here, we're going to find that there is a must, right? What is it? Where did I filter that? Where did it go? I'm in the wrong class. Oh, it's in the queue. Sorry. These things get confusing. Serial. Okay. So there's this must transaction or must group transactions property that's being exposed on these gateway sender queues. And it gets that Boolean value from its sender, the sender now being hard coded to return, or will be hard coded to return whether or not it does grouping, right? And that will come from an implementation eventually that says, hey, I'm always doing grouping or I'm not doing grouping. But if we look at where this is being used, we can find that we make some choices based on it here. Like we go into this peak events for incomplete transactions, and if we're not grouping events, we exit this. So we know that this method was added entirely for doing transaction work, which means this method probably belongs in something only constructed by the factory that constructs my transaction grouping sender. Okay, so we start looking for these and figure out, okay, how can I pull this out? well, this was in sender queue, gateway sender queue, and my factory is creating these senders, the parallel gateway sender or the serial gateway sender impulse. That's not the queue, that's the sender. The architecture is a little interesting in here, partly because some of it's reused by async event queues. So we have these two different disconnected classes, and like, how do we get there? And if we start looking at what constructs these, we'll find that in the serial gateway impl, it ends up going down to create this queue. Actually, the easier way to find it is to go to the queue and find who calls constructor. And if we find this constructor usage, it's created by this serial gateway sender event processor. Okay, now we're at a third object that we're going through to create these things. And if we find who calls this, we're going to find that it's called by this, let's say, concurrent serial gateway sender event processor object. Okay, yet a fourth class that we're dealing with here that is indirectly creating the thing that we finally want to get to. So we're starting to see that there's this path that we're going to have to create different implementations of these classes such that they create an implementation of a class that allows us to hook into that serial gateway sender or serial gateway sender queue, or you'll see the same one for parallel sender queue. We want to be able to hook in at some point to be able to extract out that one method we saw that was very specific to transaction grouping. And so as we start to back out of this, we'll find that this then is created by the remote concurrent serial gateway sender event processor. So now we're on fifth object. And this one is created by, yay, we're back to where we started from. Here's my serial gateway sender impl. So this is the thing that my factory is creating. I need a way now to create a version of this class that when it needs a event processor, that it creates my event processor that can create the other event processor that can create the queue thing, right? It's like kind of cascades down. So kind of a nasty unwind there. But if we go now and check out this next branch where we're going to extract out all of that implementation. I did all the hard work, offline. Check out. Did I not do it? There it goes. Okay, this is not working. What's going on here? Oh, I'm getting ahead of myself. Sorry. Okay, so in this commit, I've modified these classes to start creating this new parallel gateway sender impl. Or let's go with serial. Serial is kind of an easier example in some cases. So it's creating the serial gateway sender impl that has overridden this must transact thing. That's where we're talking about, hey, we don't need to do that. We can start to get rid of that must group transactions property and make those decisions. But we still have that code where it's embedded in the serial gateway sender. So what does it look like if we remove that must group transactions events from this from the abstract serial gateway sender where the implementations we're getting that making that decision on, and actually just make the decision based on the concrete type of class. So if we check that out, now we find that my grouping serial gateway sender impl now continues to override this because we haven't gotten rid of it, but it extends this new method called create event processor. And if we go back to where this came from, we can see that we took that create event processor original method that was there and created a new protected implementation for things that extend it to make their own decisions. So in this case, the original one still created a remote serial processor based on the number of threads. And this new one is creating the transaction grouping versions of those based on the number of threads. Okay. This is the one spot where serial is not less confusing because of the way that it does this thread thing. But then we can see, okay, so now I'm going to go in and create my transaction grouping remote concurrent serial gateway sender event processor, tongue twister. It extends the original remote concurrent serial gateway sender event processor. Maybe someday we can make these interfaces, you know, but we're not trying to solve all the problems at once. And it overrides that original initialized message queue. That was in there already. You can see that the concurrent version creates its serial gateway sender. If we look at the remote concurrent serial gateway sender, it creates this remote serial gateway sender. And now our new implementation creates the transaction grouping remote serial gateway sender event processor. Great. So we're creating our own thing. We're going to go look at what that's doing. Okay, it's not doing much of anything either, other than it's overriding now this create region queue, because we need to be able to inject our version of the queue that does transaction grouping stuff. Okay, so if we go and look at where this is coming from, this originally had code that created the serial gateway sender queue, created a new method that's protected, and our new implementation extends that and returns its version of that queue. Okay. And if we look at our version of that queue, there's not much in there other than we'll notice what was originally that like events thing. Let's see if I can find the code that we ripped out here. Serial gateway sender queue. That's not the right one. I want the queue. There's a big block of code that got ripped out. There's peak events for incomplete transactions. Serial gateway sender doesn't know anything about transactions. The new transaction serial gateway sender does. So we moved that method over here. I renamed it post process batch because what it was doing is basically after it processed the batch in this method here, this peak method here, it then invoked this peak events for incomplete transactions if the batch is greater than 0. So I just moved that block of code into what's called a post process batch for now. And we can see the implementation that's in serial gateway sender doesn't need to do anything, right? This is all transactional based, so it's got a no op. But the new one that does transaction grouping does that original code work, okay? Does all the grouping stuff. All extracted out in here. Now I can test this in isolation really easily too. I can go and create a test that throws stuff at this method, test that it gets, that it creates the right filtered out batches and whatever it's doing here, right? And the original serial gateway sender is largely unchanged. It just added a new method that extracted out the construction, or the post processing of those batches. So you could see if somebody else might create something that post processes the batch, or maybe they're going to pre-process the batch, which means okay, now we'll just add a pre-process batch method that does nothing, and my new thing can extend off of pre-process. You can see how we can start to add extensions here by just adding methods in that have no ops in the original, but give us a place to hook in our own changed code. Nice thing being this is all internal, we don't really have to worry about getting it right the first time. We can refactor this down the road. We just have to go refactor each of the modules we've created. But we start to get somewhere with it. Great. So still look at this though. we've got this thing extracted out. It's doing all of the work for transaction grouping in its own classes. All this code, though, is still in, well, it's in Geode WAN. And if we look at where we make that decision on which factory to construct, still down here, this is still relatively hard coded to this particular implementation that we know about. That's a great start, right? Like, we've isolated out these classes. But what does it look to start to modularize that now? And before we go there, actually, let's ask some questions about the refactoring. Everybody have any questions about the refactoring up to this point?
I have a comment, Jake. Okay, this looks very nice. I think the post process batch is nice, but also in the queues, if you look at the original code, there were some other nasty things to change. For example, in the remove method of the queue, and it's different between the parallel gateway sender and the serial and so on.
Right.
So I wonder sometimes if things get very nasty, if it's worth to do this exercise, or in the end, it's not worth, and you have to more or less do what we have done originally, because the post process is kind of easy to see. It's like a hooking something inside, but the other details are more complex.
Yeah, and I struggled with showing this version of the modularization versus showing what I had originally done. In the original work, there's actually a lot more work that was done, and there's a couple more methods that were added to account for some of that weirdness. Also, some of the weirdness that I think had to do with removing, or at least finding, like the last transaction stuff. That complicated code actually just disappeared, because once I had a concrete implementation, I always knew that if I was coming to this piece of code, I was doing transaction batching. And so I didn't have to go try to figure out if I was doing it based on the configuration. I knew I was. And so it removed that transaction grouping helper class. Basically, everything in that went away, because I didn't need to go back and try to figure out which gateway senders were doing batching. So I tried to simplify things here just for this discussion. So yes, this oversimplifies the situation, particularly for kind of the batch processing. It's just a kind of a glimpse into what we can do. I would argue that if it is complicated, that's actually a really good reason to modularize it, because we can find a way to uncomplicate the original code too, and maybe find a way to test the original code better than it was prior to that. But by adding more complication to something that's already complicated, we've now just made that situation even worse. So I think, yes, there's definitely a point where you're going to get some, you're going to get some roadblocks that make it really hard to kind of want to move forward. But I think those are the reasons to move forward with trying to extract and modularize this. It just might take a little bit longer.
Mm-hmm. Okay, thanks.
Okay. Any other questions about the simplified version of the refactoring up here? I will say that we didn't take any look at trying to fix the modularization, or the encapsulation of the must transact or must group transactions stuff in the attributes. I haven't done that in this view. There isn't any tackling of gfish in this view. If you want to look at how I tackled those, go look at the original post on the dev list. They take you to and try to walk through a little bit of the original work that was done. I didn't want to walk through that one because it's actually diverged quite a bit from what is in develop. And this is more focused on what's in develop. And I wanted to keep this one focused on just, here's this one area that we could have started with, and then figured out how to attach things to it from that point.
Jake?
If we have time at the end, we can go into more details on some of those other changes if we want to.
Hey, Jake, it seems to me that one of the headline items here might be that when you started off the refactoring, there were a bunch of instance ofs in those main starting classes. I'm wondering what the comparison is before and after, on the number of instance of checks. It seems like you've taken, what's that?
I said in that particular spot, like you were talking about that create in the gateway sender factory.
Yeah.
That create, yeah, the instances of that it was checking really was, are we actually creating the gateway sender for the real cache or for that cache creation object? Cache creation objects or any of those objects in creation are really for like the cluster config. They're like dummy versions of that object only for doing configuration. It's kind of a weird, we could have a whole conversation about that. So most of the checks were whether or not we're creating a real cache or a fake cache, basically, and then making decisions around that. Some of them weren't clear why we don't validate on the fake cache, but we validate on the real cache. But it seems like you want to validate in both cases. I left that up to trying to figure out later. As far as trying to figure out like what type of sender we are later on, there aren't a whole lot of places that check I haven't seen any places that check the type of the class type of the sender. There are places though where checks are done against the is parallel attribute. But I would argue if anything outside of parallel senders themselves need to know if it's parallel or not, we probably did something wrong, right? Like that's internal knowledge that should be inside that module. So again, trying to tease out as we start to look at this interface or things that start to come out of this is that we don't really even need that is parallel, right? Like I know I'm creating a type of parallel or I'm creating a type of serial. So the is parallel could effectively be deprecated. If we had started from the beginning with this process for the transaction stuff, we would not have that must transact or group transaction flag on the attributes, or in gfish we would have said I want to create this type of gateway sender. So we get to a point where there's some type that.
So in removing instance of checks and in replacing a field with a class, you're removing conditionals with this work, right?
Yes.
It seems like there's like the primary conditional is an instance of check, and then this secondary conditional is kind of, oh, we've made a field that could have been implemented as a different class, right?
Yeah.
Or there could have been a different class that takes what is a class with conditionals in it and makes maybe two classes without conditionals, right?
Correct. And really, when you look at good object design, right, we're talking about an object shouldn't do really more than one thing, right? Like it's either an apple or it's an orange. It shouldn't be an apple or an orange based on some property, right? So getting rid of those properties and creating those concrete classes removes those conditionals, and finding a way then where that conditional was happening is a very keen indicator. That's where you want to put that method that you're going to extend, right? That I'm going to go and do something else. So as an apple, I'm going to taste sweet, and as an orange, I'm going to taste tart, right? Cool. I don't have to have an if statement in my apple orange class. I now have an apple class and an orange class. It also makes testing easier, right? I write a test that tests the apple, and I write a test that tests the orange. I have to write a test that tests that it can convert between apple and orange, right? What happens if my apple becomes an orange? Are there other weird behaviors that happen? I don't have to test that because it's either an apple or an orange. Can't change from one to the other.
So is there a punchline here where you actually extracted out the transaction support into a separate sub project?
Yep. Hey, that's where we're going. So we're talking about the refactoring. No. Does anybody else have questions on the refactoring part up to this point? All right. So I'm going to check this out. So yeah, so as we saw, and as Bill was asking, all this is just being extracted out into its own package within the same project. So what does it look like now if we start to pull that out into its own module? So I got to tell IntelliJ to refresh itself here. Oh, it's doing that. That's not good. Okay. So we had all that stuff was in WAN. And now, as soon as it's done chunking away, we should have this now Geode WAN TX grouping. There it is. Ignore all these other ones. These are that's from the original conversion where I actually started off trying to create an SPI and then abandoned that. But I did actually originally extract out the parallel sender and the gate and the serial senders, and then I jammed them both into a default implementation. So the originals I actually extracted out into their own module called default, for lack of a better word, and then transaction was in its own thing called transaction batching. So this one's transaction grouping. So anyway, we're here. So, okay, cool. I pulled the classes out. Go away, dog. They're in their own module. But I had to do some dirty things to make it compile, because if we go look still at this factory, now because it's not in the compile class path for this WAN, I've got to try to load the class more dynamically. So to start off, okay, I know I'm going to create this grouping transaction thing. Here's the fully qualified class name, and I'm going to go load that class. This is ugly. It's stupid, but it's modularized, right? I've pulled it out. It's in its own isolated project. It's built separately. If I wanted to, I could add tests to test it separately. I didn't add any tests at this point. We'll do that later, you'll see. But it's pulled out. And it's less tightly coupled to the original WAN. But it's still pretty tightly coupled there, because it knows the name, right? But it's pretty simple. There's, JetBrains annotations. Shameless plug, use not null and nullable, please, especially on APIs. Really great. Public APIs don't yet, but I'll submit an RFC for that later. Coming soon, spoiler alert. So there we go, it's its own module. So how do we make it less tightly coupled? And Java provides this simple yet functional thing called the service loader that allows you to specify implementations of an interface in a text file, in a jar, and discover them at runtime. So if I convert this over to a service loader thing, service loader implementation, we now see that I get this resource directory here, and I've got this file under meta-imp services, and the file name matches the interface name of the factories, right? And in there, I list all the implementations I have in this module. So in this case, I've got two implementations. I got a serial and a parallel, transaction grouping senders, okay? And if I go over to the original WAN, we'll see it actually had quite a few in here already, but there's the new factories. Those factories that we created earlier on for the original serial gateway senders and parallel senders is here, okay? So now when I'm going to create my factory based on these attributes, again, still somewhat coupled here. We're now loosely coupling though based on these string names, what I'm going to call their type, okay? And so if it's parallel, I'm going to do parallel. If it's parallel and transaction, I'm going to do this transaction group and parallel sender. But we can start to see how this is whittling down to some sort of type. You could almost imagine now, hopefully, gfish create gateway sender type parallel gateway sender, right? Or maybe we even get down something as simple as parallel, right? Like, cool. I start naming these things. And then I can tell, so I pass this off to this fine gateway sender. You can see we're loading both the original and the new stuff using this new service loader deal. And a whole bunch of cool streaming service loader stuff is going on here. But effectively what it's doing is saying, hey, service loader, load all the classes that implement this interface based on that text file that's going to discover. And then I want you to iterate over them, filter out, and find me the first that either has the name that I passed in or has a class name that starts with the name I passed in. So it finds that implementation. Otherwise, it throws an exception. I don't know what this factory is you told me to create. I don't know what this type of sender is. I'm going to throw an exception. But what I'm going to get back from this method is always going to get back, not null, the factory that I want to use as my sender. And again, if we go look at this beautiful method here, there's nothing specific to any type of sender anymore here. Right? So I'm going to load these basically at runtime based on that. Okay. And as I mentioned, we can actually go and move some test stuff over here. So there's still a bunch of places where we were looking at this must group transactions, and we have tests that were in the WAN that were making calls based on that. And as a result, because the tests are over here, if we look at this, the Gradle configuration for WAN, at test runtime only, it's slurping in the WAN TX grouping to run some tests. Well, that's a smell. Let's get these tests out, get them in the module they belong in, so that we're not testing stuff across modules, especially unit testing across modules, right? So once we do that, then, oops. Okay. So we can see that, whoop, come back. You saw it quickly. But doing that, WAN. The test runtime dependency went away. There's now no dependencies on WAN on the TX WAN. And the TX WAN now has tests. And it has now some test imports. Sorry, I didn't use JUnit 5 because I copied the original tests over. But now the tests that would have been, that were already in another place in the WAN, but were specific to transactions, and now been moved over. So it's testing that validation code that, you know, it doesn't count both conflation and grouping, transaction grouping enabled at the same time. Cool. That's getting tested here, and Serial had, I think, a few more rules, so those are all getting tested here. But we can start to then bring, basically, as we start to remove that must group transactions property, start extracting that back out, then those tests start to move into here, right? And we test the things in isolation over here. But what we have now is a module that's loadable at runtime, discoverable at runtime. But we're not complete. We have still, you know, things that we need to go do, right? You saw that in the create method here. In our gateway, create gateway senders. Whoops, that's not the right one. I'm in the wrong place again, aren't I? Factory. In our factory, we still have this hard-coded behavior going on here, right? Of this property is telling me I want this string. If you go look at the original post that I've done on the dev list, it takes this to all the way down to gfish and cache XML to correct for that. By introducing a new property on attributes called type. And what happens at that point then is if you have that attribute, and I don't have the code for that here, is that this comes down to find gateway sender factory attributes.get type. Right, like I don't have to have any logic in here that checks to see if it's parallel or must do transaction events or whatever new thing we're going to do down the road. It just grabs the type from the type and lets the factory do the rest of the work. And you can see how we can, hopefully you can see how we would start to plumb that through and then start to remove this stuff like the parallel and the must transaction events, group transaction events. Because attributes is an internal object, we can go ahead and start hucking some of that stuff off anyway. But we can start to deprecate the use of those things, the parallel and the, at least in gfish commands, as it relates to gateway senders, the real gateway senders, the WAN gateway senders, not AEQs. AEQs have a whole other issue that share some of the same interfaces, so we can't get rid of the is parallel completely. But we can start to get rid of the things that we don't need anymore and focus on types, right? I create a type of something rather than a Uber something that has a bunch of properties to change its values. So there's a quick and dirty intro to extensions and modularization. Any questions?
Hey, Jake, one of the things I feel like I'd have a hard time deciding would be, should this just be like this new feature, you know, the grouping of transactions in WAN? Should it just be part of the current WAN module as its own package? Or should it be like a brand new module?
Yep.
Is there any things you look for to make that decision?
My brain always goes to module first. Like, that's just the way I think. Like, if I'm adding a new feature, I try to think about building that feature in isolation. How can I bolt this feature on the side of the things that already exist? If the thing that I'm building is super, super small, and it's not really like a behavioral change, but maybe I don't know, it's a aesthetics change, really, I probably wouldn't go this far. But for something like this, I think this was a very clear example of something where we should have done that, because it is a new implementation. It's adding a new fundamental behavior to something, and that, I think, it should always be your flag. This should be a module. Especially in cases where we think we're going to have different types of the same thing, that really leads to that module concept, right? Like, if it's just a new feature that I'm adding in and we're not going to have different types of it, but I'm adding in some whole new functionality, not just changing the functionality of something that exists, that new functionality should be a module, but maybe we wouldn't have SPIs to discover it, right? So it'd be its own project, but not necessarily an SPI to discover it.
So we should have probably had like a module that was serial and another one that was parallel.
Yeah, and so you can see that I actually, when I started to tease this out, I had a serial and a parallel, and then splitting apart all of the tests because I blur the lines, and some tests tested both serial and parallel by just changing a flag. It just got easier for me to lump them together into one called default. So I started putting just the serial and all the serial and parallel stuff into default, and then I put all the serial and parallel transaction batching into one project. But where there is a clear delineation in behavior, yeah, it makes sense to create its own module. Clearly, serial and parallel could really be their own modules, and so you could envision shipping a version of Geode as a distributor saying, okay, well, we only support parallel, so the only jar that's on the class path is the WAN parallel jar, and then we would hope that GFish would have some smarts in it that says, hey, I can only create a parallel gateway sender because that's all I have.
Jake, is it true that you could do this sort of modularization without going all the way to an SPI, just so people in the audience who might be reluctant to go all the way with that don't get discouraged?
Yes, and as I was trying to say, in response to the last question, was if it's a whole new feature and not just a modification to an existing feature, right? This case, we're talking about a modification to an existing feature. We're adding a modified behavior to an existing feature. That's inherently different types of the same thing, right? We're talking about these gateway senders. They have some sort of common behavior, and then they have a varied behavior based on the type. That's a clear place to start doing service loading. And when we talk about SPIs, we can talk about them both as public and internal. In this case, we're talking about what's an internal SPI, because we're not exposing this out to a general public as something to go implement. And we don't want to go that far right now, at least, to say, hey, here's this public SPI that you can go implement and create your own gateway sender. If we try to do that, we're going to get bogged down in trying to figure out the best way to extract out all the different interfaces and all the weird interactions between what are the WAN gateway senders, the core gateway sender code, and AEQs, because they all kind of intermix with each other. And you can see that kind of looking at the Geode WAN and the Geode core. There's still a lot of WAN stuff in core because it shares with AEQ. So one of the things we could do over time is start seeing, okay, where is that line? Maybe we pull out, maybe we have some Geode Q module that can get extracted out. The AEQs and WAN share, and maybe start renaming some things so it's not so confusing. If you're adding a new thing, let's say I'm adding on, it's a new feature that doesn't have an existing function, so I'm not modifying it. I would create a module, but it doesn't need to be discoverable necessarily. Although we do have a cache service SPI that you can implement to kind of get it hooked into certain life cycles of the cache. There's also the, in incorporation with that, there's also the earlier extensions work that I did for attaching to a cache or to a region at startup time, both in the cache XML configuration and be able to extend there. So there's some existing extension point stuff that makes adding on new functionality somewhat pluggable right now. But always think about this in terms of some sort of pluggability, some sort of extensibility, some sort of module. And that place to add that extensibility is the place where you were going to go add code in core to call your new thing. How can you make that less tightly coupled, right?
I'm thinking of another dimension too. What you did here by leaving behind this static factory method that differs from compile time to runtime, the binding between this module and the classes in your new Geode WAN TX grouping. Mm-hmm. You essentially built. You're essentially saying that the old WAN module, that this new module is part of that thing, though the binding doesn't happen till runtime. But there's still a part of relationship there, whereas you could have chosen to inject all these other alternative implementations, right? In which case, the things that you inject would not be part of the old module. They'd be more independent. And we have examples of that too with a lot of our modules. So that's another way to think of it is, is this Geode WAN TX grouping part of Geode WAN? And really it is with this refactoring, because at runtime, you're going to run into these classes, right? You're going to run into the need to load these things. It's just,
right.
They're not a compile time binding, it's a runtime connection.
Eventually that's what you're trying to get to, right? That the bindings between your modules are at the interface and at runtime and not on the class path at compile time. It's going to lead you to some better isolation and probably some better testing there, because if from module A, I can't construct module B, I'm not going to be testing module B in there. And I'm not going to have tests that are reaching across classes. Now, I might have to have an integration test, right? But I'm not going to have a unit test. And maybe my integration test says, okay, at runtime, I need module B to test this integration. But you're forcing yourself to create interfaces to mock out your unit testing and be able to test these things and build these things in isolation. And then be able to have some alternative implementation. So we come up with feature foo, and somebody says, but I want foo to do foo bar. They can create an implementation of foo called foo bar and plug it in place of foo bar and not have to go change the core code, right? And that's what we want to get to, is where we stop having changes to the core code just to add new functionality or to modify existing functionality, where we're going to have functionality side by side.
And your hand has been up for 2 minutes.
Yeah, so I know we're kind of over time, but have you thought about the user? Okay, so I one thing is I do agree with Bill that the service loader thing here is kind of a smell, right? That, I can write my code and it won't, at compile time, it's going to kind of fail in here when it's looking for these things. But I guess my other question was, have you looked into the user experience with having this as a separate module? To use this now, I have to add another jar onto the class path. I guess I'm wondering if that's how we want to present things to our users, or do we need to like create?
Well, if we're presenting
bigger
jars to
mod-
users, we've probably done something wrong.
Okay.
So this is, like I said, a very simplistic look at how we start with this. There's a more complete example on the dev list, but if you look at like, okay, I'm gonna have a distribution that has only the original stuff in it, I wouldn't ship, a distribution with the transaction grouping jars even in the distribution. But let's say I want to ship with the transaction grouping or my foobar implementation. I put those jars in that lib directory. They're going to get slurped in at runtime or added to the dependency list for runtime, right? And now that service loader is going to discover those things. Okay. If we're talking about some sort of functionality that we expect user code, downstream customer code to use, now we're talking about something that's more public, right? That's where we're gonna have to spend more time figuring out like public SPIs, maybe public APIs for things. In this particular case, this is all internal, this is all behind the scenes. There's nothing that a user interacts with at a code level here, right?
Right. I guess I'm talking more about like I try to start up a cache server.
Right.
Then I have to remember this thing, or if I don't, then I get runtime errors, I guess.
Yeah. If we're talking about people that are embedding Gemfire, that's certainly an issue, right? Because as we add new dependencies, whether they're third-party dependencies or our own modules, the class path in which you start including things becomes a bit more complicated. There are certainly different ways we could have solved that problem for embedding. Hopefully we'll move towards defining actual modules, defining dependency modules, things like that definitely help with that. Because I could imagine providing, my distribution has a module jar that just lists out all the other modules I depend on. One of them could be this transaction grouping one. And so if I have my embedded thing that pulls in that jar and pulls in all those other jars, great. Or my Gradle project that creates my Uber jar that has everything I want in it, it's going to have a dependency on this. So it's going to pull it in and create my Uber jar. I think if we start building things, as modules, people are going to get used to us as modules and things that we need to include in the class path that they want to use, and things they can leave off the class path because they're not going to use them, right? Like, I'm never going to use the old senders. I'm only going to do transactions gateway. I can leave that module off the class path, right? Technically, well, you can't really because it's dependent. There's a dependency issue there in code, but if you could, you could leave those off. As far as like the real user experience, right? Like if using gfish or cache XML, the dev list post goes into a bit more detail on that, but starting to migrate the gfish command over to something that's either like, create gateway sender -- type equals, and then I specify a type rather than parallel true or must transact true. We start defining concrete types. And then those common attributes remain common. But the things that aren't common, maybe we start pulling those off, deprecating those, and they become types of things, or they become attributes specific to that type. And as we start looking at gfish and go, well, gfish doesn't really work very good with modularization of this type of stuff. How do we make that better? So maybe gfish, starts to learn the ability to interrogate some implementation for properties that it has, right? So maybe down the road, a gateway sender factory has a way to expose the additional configuration options it has for a gfish command or a REST interface. And then, that user experience gets a little bit better over time. So we don't need to solve it all in one shot. We could start to kind of, take pieces off as we need them and try to improve on that experience.
I think there was one more question someone tried to ask before Dan asked.
Yeah, I think it was me. Yeah, looking at your changes, I was thinking that ideally, if you want to add a new module, ideally you wouldn't have to change the original code. But I think normally you are going to have the original code, especially if you are going to reuse some code. Yes. Like in this case, yes. If you want to reuse the already base code for the queues, I mean, you have to insert at least hook points inside the original
Yes.
code, right? Would be at least one thing you have to do.
Yes. And I think if you think about that, like, okay, here's the decision point. Here's where we're going to make that decision point, right? Like, if we go look at the original Q code here, let's go to serial gateway Q, right? Had that was it peak? I think it was. Yeah. So in this peak code, right? You guys at some point figured out, hey, this is where we want to stick this thing that's doing the grouping, right? It's checking for those. Do I have an entire transaction in this in this batch, right? This is where you were going to put some if statement that says, if I'm doing transaction grouping, I want to do some additional code. So right there can be that indicator that says, okay, I'm going to put a method here that's extendable that does nothing in the original implementation. The cool thing is all the tests for this code continue to run because this does nothing. In fact, you can even write a test for the original code that calls this and make sure that this does nothing, right? Because you're asserting the behavior of my original implementation does nothing, doesn't modify anything. And then you write your extension to implement there. So basically anywhere where you find yourself trying to say, okay, well, right here, I need to put in, some behavioral change based on my property. How can I extract that out? And so let's say in this particular, there was another case where it was doing some stats work. And if this, it was incrementing a stat, and if it was doing transaction group stat or transaction grouping, it didn't increment that stack. So extracting out that stat now into its own method, where the original code continues to do what it's doing. And now I can test the original code in isolation for that one method if I wanted to. And then my extension is a no-op, right? Because I'm removing that chunk of code. And the nice thing about that, as we see, is when I started refactoring, like this method went from a couple hundred lines of code down to whatever that is, 5, 6 lines of code. We start to see that same thing can happen in the gateway sender queue. If we started to extract places where we might have to do different behavior, extract those into their own methods to become smaller methods that this major method calls, I can test those methods in isolation and then do my implementation in isolation from the original code. So I would say if you're coming at this, creating a new feature or modify an existing feature, anytime you think you have to change the core code to do your work, think about how can I change the core code to do my work somewhere else.
Mm-hmm. Okay, thanks.
All right, we're about 10 minutes over. So thank you, Jake, so much for presenting and everyone for asking great questions. Currently, our next session should be November 4th and back at the usual time, which is 1 hour earlier. Alberto, you mentioned on the mailing list that you might want to talk about Q resource management. Are you still up for that?
Yeah, I think we will present something.
Awesome. Awesome. All right. Thank you all and see you next month or sooner.
Thank you.
Thanks, Jake.
See you. Bye.